Assalamualaikum warahmatullahi wabarakatuh. Today, our group will present about thermophysics. So, this slide was prepared by Nur Afika binti Gani, Mahira binti Kazan, Aina Najwa binti Muhammad Syafiuddin, and Siti Sarah binti Nur Kirut Asurai. In this topic, our group will present about specific heat and specific heat capacity, latent heat and change of phase, and heat transfer mechanism, conduction, convection, and radiation. Specific heat and specific heat capacity. So, what is specific heat and specific heat capacity? Specific heat is the quantity of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. The unit SI for specific heat is joule per kilogram per degree Celsius. Next, specific heat capacity. Specific heat capacity is the amount of heat required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. The unit SI is joule per kilogram per degree Celsius. Now, I will show how to find the specific heat capacity. So, to find the specific heat capacity, we need to use this formula, which is Q is equal to MC theta, or theta we can replace it with delta T, which is the change of the temperature. So Q is equal to the heat, C is specific heat capacity, M is equal to the mass, and theta we know that the change in the temperature. So how to find C? So to find C, we need to rearrange the formula. So when we rearrange the formula, we will get C is equal to Q divided by M delta T. So I repeat again, the unit SI for specific heat capacity is joule per kilogram per degree Celsius.
Okay, so now I'm going to explain about latent heat and change of phase. Latent heat is the heat required to convert a solid into a liquid or vapor without change of temperature. Here we can see that if solid want to convert into a liquid, it must through a fission process, and when the liquid want to convert into a vapor or gas, it must through the vaporization process. When a material change phase or condition, either from solid to liquid or from liquid to gas or the way around, a certain amount of energy is involved in this change of phase, even though its temperature is not changing. Latent heat of fission is actually the quantity of heat required to change a unit mass 1 kilogram of substance from solid to liquid state or the other way around. Latent heat of vaporization is actually the quantity of heat required to change a unit mass 1 kilogram of substance from liquid to gas state or the other way around. And next, we're going to calculation method. Okay, here we can see the first equation is Q equal to ml, where Q is the quantity of heat added or released during the phase change, and M is mass of the substance, and L is the latent heat of the process. Q here is in unit joule per kilogram. It's same with LV, latent heat of vaporization. Same with latent heat of fission equal to Q per M, where Q is the quantity of heat added or released during the phase change, and M is mass of substance. Okay, the first equation, Q equal to ml, is actually only can be used to calculate the heat loss or gain for any substance that have changed in condition or phase. Okay.
Hi and Assalamualaikum everyone. I am Siti Sarah binti Nukira Asurin and today I would like to talk about heat transfer and thermal conduction. First, heat of transfer. What is heat transfer? The explanation of heat transfer is any or all several kind of phenomena considered as mechanism that convey energy or entropy from one location to another. In other easy words, is the movement of heat from a warmer object to a cooler one. Besides, heat transfer also known as energy that move. Lastly, we need to know that heat transfer is classified into various mechanisms such as thermal conduction, thermal convection, and thermal radiation. Now, let's talk about thermal conduction. Thermal conduction is the process whereby heat is transferred directly through a material with any bulk motion of the material playing no role in the transfer. Next, conduction occurs when the atom or molecule in a hotter part of the material vibrate or move with greater energy than those in a cooler part. We can see the process based on this diagram. Apart from that, the rate of heat flow through a substance is proportional to the difference in temperature between its ends. Lastly, the heat flow delta Q over a time the interval delta T is given by this equation. Okay, lastly we need to know about the equation. First, we need to know that heat flood is the rate of heat transfer per unit area. So the equation is Q over TA equal to K delta T over L. From this equation, we need to rearrange the equation with K as the subject, and then we get the equation is K equal to QL over A delta T over T. The thermal conductivity K of a material is an indication of how good a conductor of heat it is. Lastly, the thermal conduction have two units like this shown in the slide.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Najwa binti Muhammad Syafuddin. Today I'm gonna tell you about convection and radiation. What is convection? Convection is a process by which heat is transferred by movement of a heated fluid such as air and water. There are two types of convection. The first one is natural convection. Natural convection is when convection takes place due to buoyant force, as there is a difference in densities caused by difference in temperature. For example, oceanic winds. Second, forced convection. Forced convection is when external sources such as fans and pumps are used for creating included convection. For example, using water heaters for instant heating of water and using fan on a hot day. Now I will tell you about radiation. Radiation can be described as energy from a source that travels through space or other mediums. Light, heat, microwaves, and wireless communication are all forms of radiation. These include the following. First, particle radiation, such as alpha radiation, beta radiation, and neutron radiation. Second, gravitational radiation, such as radiation that takes the form of gravitational waves or ripples in the curvature of space-time. Next, acoustic radiation, such as ultrasound, sound, and seismic waves. Lastly, electromagnetic radiation, such as radio waves, visible light, X-rays, and gamma radiation. Radiation is often categorized to two types depending on the energy of the radiated particles, which are: first, ionizing radiation. Ionizing radiation carries more than 10 eV, which is enough to ionize atoms and molecules and break chemical bonds. Next, non-ionizing radiation. The non-ionizing radiation consists of alpha particles, beta particles, and gamma particles, whereas ionizing radiation consists of microwave radiation, infrared radiation, and radio wave.